Okay guys, Pete here, N6QW, and we're testing out a little theory here about using an Arduino with a stepper motor to drive a variable capacitor in the VFO. And I was fortunate enough to find some software from a guy who calls himself brainy-bits, and it was to control a stepper motor with a rotary encoder, and it uses an Arduino Uno and a little board and a stepper motor that I bought 5 of them for 12 bucks, and doesn't have a lot of torque, so we don't have a very large capacitor, just to prove the concept of tuning this. Now I want you to note this little variable. It's actually a differential, because that's what I had. It was small. On this top plate right here, I put a dot, and I've set the tuning rate to one step in the software. And I've done something else here. Is I added this was not in his software, but I added how many steps you take, and you see the -1 that tells you that that's going the reverse direction from the normal turning. So I can keep track of the number of steps, and actually the software does. And there's a little button right here, and you push this button and it actually zeros, takes you back to where you started. So we have to do a little more refinement, because in actual use what we'd have to do is we'd have to bring it to 0 every time we got done. So I'm trying to find somebody who knows how to use the EEPROM that will take the last reading as you're powering down, and then essentially when you start up, it takes that reading and makes it 0. And it can be done with an EEPROM, except I just have never used those before, and I asked if anybody on my blog knows how to do that. I put a very large oversized knob in here, and so we're going to turn this a little bit, and I'm starting to turn it plus, and I've done 38 steps so far. And you'll see what's going to happen here as I keep cranking this thing. So as I crank it, and you get up to about 400 steps or so before you get it. And I started off with actually the capacitor in the center. So this way, when you start this thing up and at the 0 position, it'll be right in the center of the VFO range. And I put a little dot on there, and it's moving pretty slow. And you gotta get up around 400. Right now I'm at about 200, but maybe you can observe the dot moving. And then what I want you to see is when I zero the meter, it'll go back to the 0 position. Now the neat part of this is to for my friend Bill, N2CQR, who only likes analog VFOs, and he's got what he calls an HRO-ish receiver. Okay, we start up again. I got a phone call. Anyway, you'll see the dot is almost, and the variable capacitor is completely out of the upper range, since this is a differential. And right now we're at about 523, something like that, 530. Now watch what happens when I push the little button here, this little button, and watch what happens to the capacitor plates, and watch the dot. Now, probably in practice, I set this to 1 step so you get a real fine tuning. You probably want to make that step something like 2 instead of 1 step at a time, because it's moving really, really slow. But he had it at 50, so that thing just kind of buzzed through there. And if you're mechanically tuning this with the stepper motor and the encoder, you then get in the point. Okay, now what happened was, over here, this now reads 0, or it reads 1 because I just bumped the dial. So you have the ability to set that. Okay, it got set back to 0 now. All right, now I'm going to go tune it in the other direction. I'm going to tune it counterclockwise, so it'll tune the low end of the band, and we should get up about 500 steps. Takes it to fully meshed. And hopefully you can see this changing. But I think this is a very feasible concept. And with a very small capacitor, these pretty cheap stepper motors can actually do that. So when I get done doing this here, I'll show you the mechanical part of this, how I put the thing together. It's just got a bunch of spacers, a piece of scrap aluminum, and it's got some a few bolts on it and a spent piece of PC board. Okay, we're almost fully closed, and it's about 530. So about 1,000 steps. About 1,000 steps. We'll go through the whole range. Now let's watch what happens when I'm going to push the 0 meter here, and so now it should be moving pretty slowly back to the center position. You can follow the dot there and just observe that. So this is a feasible concept that I see for replacing the HRO dial with the gearbox with a stepper motor and an Arduino. And if I can get the EEPROM to work, what will happen is it'll remember where the last position was, because you have to set this from 0 for the steps to work. Otherwise, if you shut it off with the VFO about 3/4 of the way, that's going to become the new 0 position, and you want the 0 position to be in the center. So now, if we look at our display over here, I've just moved the dial, but it goes back to 0. So anyway, this works. All right, let me show you what's involved here. We have just a simple coupling. I found some piece of plastic that fit both shafts, and it's just friction fit, and you'll see all the spacers in there because I didn't want to cut this. And there's the little stepper motor. So the stepper motor, the board over here, and the stepper motor and the board by themselves, I've seen them for about $5, but I got 5 of them for $12. And you have to have a 5-volt power supply to run the motor, because the Arduino, even though it has 5 volts, cannot supply the current for that motor. And of course, this is something that wasn't in the original software, or what I saw on the YouTube from brainy-bits. I added this, and it's pretty cool, because I can keep track of the number of steps plus or minus. Now, what you could do is you could actually calibrate this thing with a nomograph, so that you could look at the where the positions are, a number of positions, and set the frequency via a nomograph, which would be okay. Or you can add some more software into the basic sketch, so that essentially what you would be doing is you would be here, I'm going to 0 the meter. It should have moved just a little bit. Essentially have a frequency counter. You set up the Uno so that it has a frequency counter, so that reading the signals with some sort of sensor, and then you could also display the frequency. But this works every time to set it back to 0, because it keeps track of the number of steps, either clockwise or counterclockwise. And with a big old dial here, I'll show you my big old dial. A big old dial, boy, you can really tune this thing. It turns relatively fast, because you're taking the number of turns on the large dial. So again, about 530 will essentially make it fully open. So let's see if that's the case. And then pushing this push button, it's keeping track of the number of steps, and essentially put you back to 0. So let's see what's happening here. We're about 38, 39. Here we go. 80. I must have a loose connection here. There you go. We're at about 200. And it doesn't peel them off, but when it gets to 0, it pretty much tells you the display will read 0. And you can see the LED flashing. So it takes about 1,000 steps to traverse. Actually, it should take 2048 to make a complete 360 degree turn. So half of that, it'd be 1024, would essentially be the, getting some negative things here. May have a loose connection. Okay, it's 0. Why is that reversing? Oh, I was pinching the wires. Okay, there we go. So fully open should be about 500. Yeah, it's going backwards. May have a problem with the encoder here. Nothing like slop together wiring to cause problems, but anyway, it's moving back to its 0 position, which is about halfway open. There you go. Okay, Pete, N6QW here. I need to probably resolder some of these wires. One of them looks like a kind of a flaky connection, so we're missing some pulses here. But anyway, I think this is the feasibility. This is clearly evident. Anyway, N6QW.